Hello and welcome to the Beef Age, the Teagasc Beef Podcast, for all your latest news, information and advice for Irish beef farmers. I'm Egan, and on this episode, with sustainability becoming more and more important in the production of Irish beef, I spoke to two experts in the area to find out more. Professor Sinead Waters, researcher in Teagasc Grange, and Dr. Dominika Krol, researcher in Johnstown Castle. I first asked Dominika what are the main sources of emissions of gases from farms.
I think we need to start with what the gases actually are. So they're divided into two main categories, the greenhouse gases and air pollutants, okay? So the greenhouse gases obviously have negative impact on climate change. And these gases are methane, nitrous oxide, and carbon dioxide. And in agriculture, the first two are the most important. So methane represents around 2/3 of emissions and nitrous oxide the other third. And when it comes to sources, it's nearly 60% come from animals themselves, mostly from enteric fermentation methane, and Sinead will cover that. And 30% from soils that were fertilized by either manure or synthetic fertilizer or animals grazing on pasture, okay? And then the remaining 10% comes from mainly from management of animal manures, so be it housing during closed period and slurry storage. So that's on the greenhouse gases. And then on the other hand, we have air pollutants. And here the most important one is ammonia. So practically all ammonia is produced by agriculture, and we have targets to reduce these emissions. However, we've actually been in breach of our targets continually since 2016. So in terms of sources, ammonia comes mainly from management of animal manures. So it's housing, slurry storage, and land spreading of slurry. But it also comes from grazing animals, so whenever animals excrete on pasture, and finally also from spreading of synthetic fertilizer. So really it has to do with any material that contains nitrogen that is deposited on the soil.
Sinead, in relation to reducing greenhouse gases, it is something that farmers have heard a lot about lately. Why is there such interest in it?
Yes, Catherine, there's a big interest now in greenhouse gas emissions amongst the farming community. And that's mainly because agriculture accounts for more than 34% of Irish greenhouse gas emissions. And in line with EU legislation, Ireland will need, as Dominika said, to decrease national greenhouse gas emissions. And that'll be by up to 30% by the end of 2030. And one of those greenhouse gases, methane, is in fact responsible for nearly 60% of agricultural emissions. So reducing methane emissions from agriculture will be key really to meeting our targets.
So Dominika, what are the main ways of reducing ammonia emissions?
Okay, Catherine. So there's been a lot of research in both internationally and in Teagasc on what's called mitigation measures. And there are actually measures, some of them that work both on greenhouse gases and ammonia. And then there are some that are specific to ammonia only. So in general, the main options that we have are things such as protected urea, low emission slurry spreading, liming of soils, having clover in your grass sward, good animal genetics and health, and extended grazing. So these are kind of the main measures that we work with. And these measures are targeted at either animal or soil level to make the production more efficient. So what's important to remember here is that when reducing ammonia losses, by, for example, changing to protected urea or low emission slurry spreading, we improve our nitrogen use efficiency. So we retain more nitrogen in the system, and this really needs to be taken into account when we look at our fertilization program. So we do need to account that improved nitrogen use efficiency by reducing the synthetic fertilizer applications. And you know, that's also positive for farm finances, because normally the fertilizer bill is one of the largest on the farm.
So switching from products such as canned to urea can help reduce some of these emissions and fertilizer costs.
Absolutely. So protected urea products offer benefits of, first and foremost, preserving yield, quantity and quality while reducing emissions. So protected urea reduces ammonia loss by nearly 80% compared to straight conventional urea, and it also reduces nitrous oxide by nearly 60% compared to can. And why we're looking at, either comparing protected urea to can or straight urea, it's because can is well known for having large emissions of the greenhouse gas nitrous oxide, and urea is known for having high emissions of ammonia. So swapping one for another, we would be fixing one issue and then creating another one. So that's why protected urea actually reduces both of these losses. And it's actually compared, its performance is very comparable to conventional nitrogen fertilizers. And maybe just important part to include here, Catherine, is that it's not, it's not only we're talking about fertilizer formulation here, but the general rule of fertilizer management is what's called the 4R rule. Some people are already very familiar with it. So it's the right fertilizer source, right rate, right time, and right place. So, even though we're talking about fertilizer source or fertilizer formulation, that being protected urea, we also need to remember the other three parts. So it's vitally important to best match plant demand, increase nitrogen use efficiency, and that reduces any negative impacts on the environment and reduces financial losses as well. So in terms of fertilizer source, so that's what we've been covering in terms of changing fertilizer formulation from bead can or urea to protected urea. And protected urea has already been used, on a number of our own Teagasc farms and commercial farms, and it's included in the Teagasc fertilizer programs for farmers. So they are widely available and farmers can avail of those. So that's on the source. On the rate, look, there's that needs to be obviously matched with the planned demand. What we've been saying over the years is that ideally fertilizer would be split. This is very familiar to beef farmers that farm grassland, where the fertilizer goes out in a number of smaller splits, as opposed to having fewer and larger splits. What it means is, if there is a potential for losses, that potential is reduced by having a lower rate of fertilizer application. With regards to time, I'm looking outside the window now with the really warm weather, and we're suffering drought here in Wexford in a lot of places. The planned demand is unfortunately not there at the moment. So depending on the grass growth, many farmers can still fertilize. Some of them can apply their normal fertilizer rate. Some of them, because of the reduced plant growth, would be applying a reduced rate. And some of them would be holding off with fertilizer because, this is not the right time for it. And then with regards to right place, it's the actual placement of the fertilizer, close to the plant where the plant needs it. So depending on what it is, what type of fertilizer it is, especially with compounds or with P, for example, it needs to be strategically placed where the plants need it.
In relation to low emission slurry spreading, what impact can this have on farm level versus splash plate?
Right. So, look, obviously, from my point of view as someone working with emissions, the most obvious benefit for me is to limit ammonia emissions. And this is pretty much our biggest ammonia mitigation measure that we have in our arsenal. So the way this technology works is it reduces area covered by slurry, and this is called emitting surface. And if this surface is smaller, like how it's done in the low emission slurry spreading, where slurry is deposited either in bands on top of grass or directly on the soil, the emissions are lower. Okay, so that's a huge benefit. But there are other added benefits of using this technology, such as less grass contamination. And what it means is that animals can go back to grazing paddock earlier than if the slurry was just broadcast. And then the other big one, which is getting more attention in recent years, is odor. Because slurry is deposited on a smaller surface or closer to the ground, so there's less contamination or less odor. So it's just very nice and tidy way of applying nutrients, and it does provide a better nitrogen use recovery and kind of better fertilizer value of that slurry applied on the farm.
And in relation to the research that's currently ongoing, and what future options are available on the horizon?
Right, so we're currently carrying out research into the efficacy of different slurry amendments that could help reduce emissions during slurry storage. That's a big one because our housing configuration with slatted tanks under animals, it actually makes it quite difficult to mitigate emissions from slurry storage. So the options there are quite limited, and amendments might be able to help there. Because they can be just put into the tanks as is, and there's very little retrofitting or more technology added onto the tanks. And we've been getting very good results with regards to reducing ammonia emissions and also greenhouse gases. And this year we're starting new projects to better quantify ammonia from storage and land spreading, starting to use combination of treatments as well to reduce emissions. So we've been looking maybe at amendments or low emission slurry spreading in isolation. And now we're starting to combine those treatments to see the best benefits of those. And we're also looking at the role of anaerobic digestion in managing emissions from manures and co-digestion of manure with grass feedstock and the different grasses with mixed species grasslands. So there's a lot of happening in this space, and they're very ambitious projects. So they cover a wide range of impacts. So we're not looking at any emissions in isolation, but we can trace ammonia, greenhouse gases. We're looking at grass agronomy, at soil fertility, and microbiology. So it's very exciting. We're trying to cover all our bases so we can look at system in a very holistic way.
Hopefully, some of these methods of reducing emissions will be able to be demonstrated on farms shortly.
Fingers crossed, Catherine. Yeah, it'll be very exciting to see this.
Sinead, you mentioned that methane is responsible for nearly 60% of agri emissions. Why is methane such a big problem?
Yes, Catherine, methane is a really major issue for us as it's a greenhouse gas that's 28 times more potent than carbon dioxide. The other thing is methane stays in the atmosphere for about 12 years, and during that time it basically traps the heat like a sponge, and this warms the atmosphere and causes temperature to increase, contributing to global warming. So just in terms of how it's produced, we know that grass is an economical way to feed cattle, but the animal itself cannot digest the feed. So it needs the help of microbes in it has a specialized stomach called a rumen, and it has microbes within that rumen called methanogens and other bacteria and etc. that can actually break down the feed. But during that process, in return for breaking down the feed, the methanogens produce what we call methane. And this is a potent greenhouse gas that's emitted out of the animal into the atmosphere and is very dangerous in terms of as a greenhouse gas. Methane is also produced, I suppose, from stored manure and slurry on farm. And we're trying to develop, I guess, mitigation strategies so that we can reduce the methane emissions from those sources. But to date, there's been, unfortunately, little success in that area, and there's an urgent requirement to develop, I suppose, innovative strategies to reduce methane emissions from agriculture in Ireland so we can meet our future targets.
So, what do you see as the solutions?
So the two main areas of research at the moment, which is active in Ireland, are solutions in terms of breeding cattle for lower greenhouse gas emissions, while at the same time making sure you're not affecting any other production traits such as feed efficiency. And this work is going on in performance. This work is going on in collaboration with ICBF, the Irish Cattle Breeding Federation, in Tully, performance testing station in County Kildare. So we have a number of projects with the ICBF there that are working on trying to develop strategies to actually breed cattle that have a lower environmental footprint. The other strategy that I'm very much involved in myself is basically from a new project that we recently got funded from the Department of Agriculture, and that's on the development of effective additives that can be added to basically to slurry or stored manure or as feed additives that can actually be used to reduce methane emissions from enteric fermentation in the rumen. And an important aspect to the project would be we need to ensure that these additives are cost effective, that they can be easily delivered to animals, even at pasture, and do not result in any residues in the meat or milk products. So that's where the most activity is ongoing really at the moment.
And Sinead, what are the advantages of multi-species swards, including clover, in reducing emissions from methane?
Yeah, this is a very interesting area of research that we're hopefully going to get involved in as well here in Ireland. So international data really will show us that methane emissions emitted from animals fed legumes or clovers were lower in animals fed than in animals fed grasses or perennial ryegrass. However, in relation to clover itself, we find that while some work does show that clover inclusion in pasture can reduce it reduce methane emissions, some other studies found no effects. But here in Ireland, in a dairy study in Moore Park, they found that white clover inclusion in grass swards, when that was fed to cows, that the animals actually tended to consume more and emit less methane than cows fed an only grass diet. And more recently, we looked at a little bit more research into the microbes that exist in the rumen of those animals, and we found that the microbial composition of these dairy cows fed the perennial ryegrass and the white clover sward had different bacteria and methanogens in their rumen, which was interesting. And we're going to follow up on that in terms of abatement strategies. What we'd really like to do is to investigate further in beef cattle here in Ireland. And our plan is to assess if we get any novel feed additives that are effective in reducing methane emissions. And if they're fed to animals on grass with clover inclusion, that might give them an enhanced effect of the methane abatement. So we have some projects planned for that, to look at additives in animals that are also fed on clover compared to perennial ryegrass.
And will the reduction to methane production enhance profitability, Sinead?
Yeah, we know, Catherine, we know for a long time that methane production in the rumen is actually a very wasteful process. So when methane is emitted by cattle, it can actually result in a loss equivalent of about 10% of the energy intake of the animal, which we could use it for productive purposes. So, and also preliminary data from one of our projects that is based in Tully with the ICBF, a project that's called RumenPredict, that's funded by the EU and Department of Agriculture. This project has shown already in beef sucklers that reducing methane emission production enhances profitability. And based on the data that we've generated so far, we're starting to see a negative correlation or a negative relationship developing between methane yield and the replacement index. So basically what that's telling us, it's telling us that when methane yield reduces in these animals, that we tend to have a higher ranking on the replacement index. So that's really good news for the beef industry.
You mentioned the collaboration with ICBF at the Tully Research Centre. Can you describe the studies currently ongoing there?
Yeah, I can. So really in Tully, what we're doing is through a number of projects funded by the Department of Agriculture here in Ireland and EU funding, 6 new green feed machines were installed into the ICBF performance testing station in Tully. And these machines are, very recent technology and efficient technology to measure methane emissions. And we do that from hundreds of beef cattle going through Tully every year. And these machines measure methane output quite efficiently over maybe up to a 3-week period, and allows the researchers to get an accurate reading of the methane and carbon dioxide from each of these animals. So in Tully, the cattle are undergoing a 120-day finishing period. Then we add a 30-day acclimatization period where they're trained into these green feed machines. And then after that, the methane emissions is estimated over, as I said, roughly a 3-week period. So already we're seeing, natural variation in terms of methane emissions amongst the animals. And that would tell us that we should be able then, therefore, to breed for low methane emissions. So what we're doing is we're measuring feed intake, weight, and then feed efficiency. But as well as that, now we're measuring methane as well. So therefore, we can examine the relationships that exist between feed efficiency and methane emissions and select animals then that have a high versus a low methane emissions. And we can study the microbes that exist in their rumen. And this can give us important information really to help us design methane mitigation strategies in the future. But in addition to that, all of the studies in Tully are feeding into the genomic selection breeding program. And that's really essential because all the animals are genotyped. So we know what their DNA code is like. And basically we can make a link between the methane emissions data and the DNA code and use that information to find regions of the genome or their DNA that controls for methane emissions and also for feed efficiency. And then we can build that into the breeding program. And that information is really important for us so that we can breed cattle with a lower environmental output and be more sustainable. in the future.
Farmers in the Beef Data Genomics programme are genotyping 60% of their herd and have been for the past number of years. So it's great, Sinead, that this research is building on this.
It is, Catherine, absolutely. And I suppose this is due to the collaboration that's ongoing between Teagasc and the ICBF and the Department of Agriculture, that we can actually build on a new variable, a new measurement into that process. So currently, as I said, they're measuring feed intake, they're measuring weight, and also then feed efficiency measurements. But now we're adding on methane emissions on that. That's being recorded so that we can build a measurement into the breeding programme and build on this every year as more and more cattle are going through the Tully performance testing station, and then ultimately we can enhance the genetic gain of the beef population and have a lower environmental output. And over time, this will really help us in terms of increasing the economic and the environmental sustainability of the beef sector.
Dominika and Sinead, you're both featuring in the Sustainability Day in Teagasc Grange virtual week. What can farmers expect to learn and see on the day, Sinead?
So yeah, it's very exciting. On July 8th, the day will be dedicated to environmental sustainability. It's going to be called Beef Sustainable Production, where policy meets practice. And on that day, we'll be discussing what steps farmers can take to reduce the environmental footprint of their cattle enterprises. And the latest Teagasc research on reducing greenhouse gases, improving water quality, enhancing biodiversity, and also protecting our soils. All of that will be covered on the day, Catherine. So we're really looking forward to it.
Sustainable beef production where policy meets practice sounds like a very interesting day. Thanks for joining me on the show.
Thanks, Catherine.
Thank you.
That's all for this week's episode, and my thanks to Dominika and Sinead for joining me on the show. Don't forget, Teagasc will host a virtual beef week from Monday the 6th to Friday the 10th of July. For further details, keep an eye on the Teagasc website, Facebook and Twitter pages. You can catch up on all other shows and interviews from the Beef Edge podcast on the Teagasc website at teagasc.ie, or you can listen on Apple and Google Podcasts as well as Spotify. Don't forget to rate, review and subscribe so you never miss a show. For all other updates from our beef programme, keep an eye on our Twitter and Facebook pages. Until next time, I'm Katrin Egan and thanks for listening.